All right, folks, welcome. In this section, we are going to talk now about graphing linear functions. So last section, we looked at the different forms of linear functions, standard form and slope-intercept form. In this video specifically, we're going to talk about how to graph linear functions written in standard form. So again, a review, standard form is written always as ax plus by equals c, where x and y are on the same side of my equation. A and B are numbers in front of those variables, and C is the number by itself on the right side. A, B, and C, again, are the numbers that make each linear function different from the other. So let's say that I give you 2x minus 4y equals 12. Again, my number 2, my number negative 4, and the 12, those are going to represent, in this case, A, B, and C for this linear function. So what we're going to talk about today is how do we graph linear functions written in standard form. So in order to graph things written in standard form, an easy way to do this is to find what's called an intercept. So an intercept is going to be a point on a graph where the line crosses the two respective axes. So on any sort of graph, remember that you always have the x-axis, which goes left to right, and the y-axis that goes up and down. The positive versus negative would mean if I'm going up and down, or right versus left, okay? So the intercepts are the points where it crosses here the x-axis shown in red, and where it crosses the y-axis shown in blue. In order to draw any sort of line, all I need are 2 points. Once I know 2 points, then I know what my line is going to look like, assuming, again, it goes at a constant rate of change, meaning it goes up or down by the same amount every time. Now, the formal definition of an intercept is the value of the other, or the value of one when the other equals 0. So the x-intercept is the value of x when y equals 0. Okay, and then the y-intercept is the value of y when x equals 0. And you'll see that in the points. Here's my x-intercept. It's my value is 1 for x, but notice that my y value is 0. So it's my value of x when y is 0. And then my y-intercept here is my value of y, which is negative 2, when my x is equal to 0. Now, how the heck, given an equation in standard form, how do I find those intercepts? That's what we're going to look at. So in this first example, again, all we're going to do today is graphing. So we're going to talk about how to find these intercepts. So to find the intercepts, we're going to use the definition of an x and a y-intercept. The x and y-intercept is the value of one when the other equals 0. So let's say that I want to find the x-intercept. So if I'm going to find the x-intercept, I'll do this in red. I'm going to take my equation 2x plus 3y equals 6, and what I'm going to do is I'm going to plug in 0 for y, because the x-intercept occurs when y is 0. So if I plug 0 in for y, I'm going to get 2x. 3 times 0 drops out. I'll get 2x equals 6. And therefore, by solving that, by dividing both sides by 2, I'll get x equals 3. So I know my x-intercept is right here at 3. I can do the same thing for my y-intercept. The y-intercept occurs when x is 0. So I can do 2 times 0 plus 3y equals 6. This is going to drop out, and I'll get 3y equals 6. Divide both sides by 3, and I'll get y equals 2. And I know that my y-intercept is right there. So again, my x and y-intercept are the value of x when y is 0, and the value of y when x is 0. It gives me 2 points, which then, using straight edge or whatever, if I just connect those 2 points and draw through, I have my line. So again, I have my 2 intercepts, and then I can draw my line through it. Notice, side note, when I draw my line, I'm extending through the points. I'm not stopping at those 2 endpoints, and I'm drawing arrows on either side to represent that this line would continue in that direction, because remember, it's a constant rate of change that doesn't end. Now, notice as I did this, that when I want to find the x-intercept, the y canceled out. Okay? When I wanted to find the y-intercept, the x canceled out. So there's kind of a quick shortcut way to do this, and it's called the cover-up method. And the cover-up method is a pretty neat little shortcut that's going to do the exact same thing that I just did. So imagine here, I'm just going to place a little box here. Imagine if I want to find the x-intercept in this equation. What I can do is take this little box, and let's say I want to find the x-intercept. I'm going to cover up the y and the number attached to it. And notice what's left over is 3x equals 12. Notice what happened is the y canceled out, which is very similar to what happened over here. By solving that then, I'm going to get x equals 4, and I know that my x-intercept is going to be at 4. Now to find the y-intercept, I'm going to take that same box, and now I'm going to slide it over x, covering up the number in front of x and x. And what I get here is I get negative 4y equals 12. And notice how I attach to it the minus sign in front because that 4 is negative. Then if I were to solve for y, divide by negative 4, I'm going to get negative 3. And therefore, my y-intercept would be there. And again, these are just, even though we're using a different form, it's finding the points of 4, 0, and it's finding the y-intercept here of 0, negative 3. And those 2 points, again, allow me to draw my line. Okay? Oof, a little bit off, but that's okay. Draws my line, it's going to look like that. So that's a quick way to do it called the cover-up method. If you obviously don't have that little box on your screen, you can use your finger or pencil to cover it up. All right, so let's have you guys try 2 examples here on your own for C and D. Pause the video here. I want you to find the x and y intercepts, plot those points, and graph it. I'm going to give you a couple seconds here and let you guys solve this one on your own. All right, bringing it back, here's what you should get. For the first one, you got your x-intercept at negative 6, 0, y-intercept at 0, 3. Got a line that goes upward. So notice my first 3 examples, all 3 of those lines had an upward slant to it, and that is because one, either the x or the y, one of those intercepts was negative, which forced it to kind of move left or right or up and down. In the second case here, notice how I get an x-intercept of negative 8 and a y-intercept of negative 4. Notice the difference here. When both those intercepts are negative, now I have a line that's going downward. Whoa. So interesting there how that one works. It's the same as if I were to have 2 positive values there, it's going to go downward. So again, the idea here is using that cover-up method of definition of intercepts to find the intercepts and graph. All right, now next 2 examples, I'm going to give you guys some equations that are not written in standard form. They're going to be looking a little weird. So in example E here, I have 2x minus 20 equals 5y. So something we did last section. It's not written in standard form, even though it looks like it. Notice that I want x and y on the same side, and here x is on the left side. There's my equal sign, so 5y is on the right side. So what I need to do is move some things around. I want x and y to be on the same side. So what I'm going to do is I'm going to take that 5y and subtract it from the right side to the left side. Okay? At the same time, I know I'm kind of all over the place, I can add 20 from the left side and bring it to the right side. So in the end, what I would have is this. The y's would cancel. The 20's would cancel. I'm going to have 2x minus 5y equals 20. That is written in standard form because notice x and y are on the same side. So then using my cover-up method or by knowing intercepts, I know that 2x will equal 20. So therefore my x-intercept would be at 10, 0. And then lastly, my y-intercept would be negative 5y equals 20. So solving for I, I'd get negative 4, which means I have an intercept at 0, negative 4. So plotting those 2 points, I have x at 10, y at negative 4, and then I can connect those 2 points to draw my line. So here, if it's not written in standard form, we're going to have to move some things around. All right, last example here. Well, holy cow, that doesn't look like standard form. That looks like slope-intercept form. And guess what? That's because it is. Now, we're going to learn about slope-intercept form next section, or a little review on that. But if you ever want to write something in slope-intercept form in standard form, again, I want x and y on the same side. So notice I got y on the left side, but x is on the right side. So in order to write this the correct way, what I need to do is bring this x to the other side. So I need to do the opposite by adding. Okay, so that would cancel. And what I'm going to get here is I'm going to write in the right order, 2x plus y equals 8. Now notice when I wrote it here, y started, so I could do y plus 2x. But I don't want to confuse myself. Since the 2x is positive, the y is positive, I'm going to write in the same order. But what that then allows me to do is write 2x equals 8 to find my x-intercept of 4. So I got 4, 0 there. And then I can use my y equals 8. Whoa, that's solved already. So that means my y-intercept is at 8. Plotting my 2 points, I get 4 and 8. and I can then draw my line between the two holy cats in pajamas. And again, that was using slope-intercept form to write it in standard form. Whatever tickles your fancy. All right, last example here, babes. What if you get something where it just has x or just has y? So in this case, notice this equation says x equals -4. Well, x equals -4, well, wait a second. There's nothing there, there's nothing for y. If I were to find my x-intercept, sorry, I used the right color. If I was to use my x-intercept, I got x equals -4, so that means my x-intercept's at -4, 0. So again, on my graph at -4, but notice in the equation there's no y at all. Now, a common thing for students to say is, okay, if there's no y, then that must mean that y equals 0. But y equals 0 is actually a point on the graph. It would be right here. But y is not 0. Y is not even there. Okay, so that means it's not 0, but there's just no y. So this is it. All we have is an x-intercept. So here's what we got to think about. With there not being a y, that means there is no y-intercept. It means the line that I'm going to draw cannot cross the x-axis. So here, I'm just going to draw this in yellow. I'm going to draw a line that can't cross the x-axis. So how the heck do I do that? Well, the only way possible is to draw a line through my x-intercept. It's got to go through that point, but it can't cross the yellow line, which means it's got to be a line up and down. This is known as a vertical line. So a vertical line, you will always see just x by itself. So then what does that mean if I have y by itself? Well, that means my y is going to tell me my y-intercept. And since there's no x, that means that I cannot cross the x-axis. So how do I draw a line through that blue dot, that blue point, without crossing the x-axis? The only way possible, whoopsie daisies folks, is to draw a line side to side, and this is known as a horizontal line. So again, this was two special types of cases when you have vertical and horizontal lines, but you would graph it the same way you would in standard form by understanding the concept of an intercept. All right, last example here we're going to do is just a little modeling problem. So here you're planning an awards banquet that need to seat 180 people total. And what you have to do is rent tables. So there are two types of tables you can rent: small tables that seat 6 and large tables that seat 12. Just a quick little typo there. It says 10, but it should be 12 people. And here we have an equation written in standard form that represents this situation. So we have 6x plus 12y equals 180. So given this equation, you can recognize that 6x represents the small tables, where x again is the small tables. 12y, y would represent the large tables. And then 180 is the total number of people that I have. So 6 and 12 represent the number of people at each type of table. So x and y are those large and small tables respectively. So my goal is to try and graph this equation similar to what we've been doing by finding the intercepts. So to find the intercepts, again, what I'm going to do is think about my x-intercept as the value of x when y is 0, and the y-intercept as my value of y when x is 0. So in a simple way, to find my x-intercept, I'm going to take 6x and set it equal to 180. And for my y-intercept, I'm going to take 12y and set it equal to 180. Again, assuming that when I plug in 0 for y or 0 for x, that term would cancel out. Solving for each of these, I would get 30 and 15. So plotting these 2 points on my graph, 30 would go on my x-axis, 15 would go on my y-axis, and then what I would want to do is connect those 2 points with a straight line as best as I can. There you go. All right, so next question, it says then find 4 possible solutions of the context of the problem. So again, what we're doing is we're renting tables to seat 180 people at a banquet. So the intercepts, starting here, when I look at the y-intercept of 15, what this means is that as a point, again, this is a value of 0 and 15. So as a point, this means that I want 0 small tables and 15 large tables. Oopsies. For the x-intercept, where you have 30 and 0, this means that I would want 30 small tables and 0 large tables. So this kind of gets into the purpose of the line itself. The line itself, if I were to pick a point that falls on this line, so say for example right here, let's say that looks to be 12, 9. What this would represent are 12 small tables and 9 large tables. So if I pick any point that falls on this line, that's going to tell me the combinations that I need. So I'll say, for example, 12, 9. So real quick, what I would like for you to do is pause the video. I found one of them for you. Can you find 3 other values that would satisfy this problem? And here are some samples. I have 6, 12, 25, and 26, 2. The reason why all these points work is, again, notice all these points fall on the line. If I were to take these values as well, so for example, 6, 12, and plug it back into my equation, so 6 in for x and 12 in for y, what I'm going to get every time is 180. Now, obviously, if I'm going to choose which combination or which point I would want to use is obviously going to depend on maybe the size of the banquet hall and the size of the overall tables. But again, this is a helpful way in a real life situation that you can kind of think about how I want to arrange this banquet based on the table size and the number of people that I need.